It's a pleasure to welcome you all for my mathematics class. Today let me solve the problem, a string problem, and where the wave equation is discussed. Here you see that this is a problem in which a string of length L is stretched between two ends. You see that this is a string and it is stretched between two ends. It is like this, it is 0, 0, this is one point, and this, let us take this to be OA, and this length is L, and this is L0. And you see that the string is stretched between two ends, O and A, and that it is subjected to a vibration by giving a velocity. And when the velocity is given, when a velocity speed is given for its vibration, you see that in between 0 and L by 2, in between and 0 and L by 2, the value of V is given to be Cx, and that the value of V is C into L minus X in the other interval, namely L by 2 and L. Now we are asked to find the displacement, determine the displacement y of xt. In the sense, we have to find the value of this function y of xt, which is nothing but the displacement at any point x and at any point of time. What is that? We are going to find the displacement y of xt at any point x on the string at any point of time. So this is what we are going to do. And you see that for this problem, so you must know the one-dimensional. I will give you the method of doing it. See, if you systematically approach the problem with understanding, there won't be any confusion in getting the answer. Otherwise, the students normally get confused while doing the problem. They normally meet with some confusions in the middle of the problem. See, that can be overcome if you have the systematic approach and also an understanding over the subject. Okay, now before that you must know what is a one-dimensional wave equation. See, you see that one-dimensional wave equation, see, wave equation is, it is nothing but dou squared y by dou t squared is equal to alpha squared into dou squared u by dou x squared, where this alpha squared is a positive term and it is t is nothing but the tension that exists between when it is stretched and fixed at the two ends O and A, and m is the mass per unit length of the string. So this is the idea here. Now you say that this is, first of all, we must know how to solve this differential equation. This is a partial differential equation, and here you must know that find y of xt. First you must know that find y of xt. See, only when you find y of xt, that means solve this differential equation, then only you will be able to find the displacement at every point and at every point of time. Then only you can do. So our job is to find what is y of xt, and this is one part. But this y of xt, it has got three solutions. What is that? There are three solutions for this y of xt, out of which one is the most suitable solution, and that one can only be applied to get the value of y of xt at every point x and at any point of time. So that I will write afterwards. Then this is the first thing that you must know. Second thing is that you must be able to fix the boundary conditions. Unless you are able to fix the proper boundary conditions, you will not be able to do the problem. So you see that first you must be able to write the, see here for this, let me first write the boundary conditions, then I will write the what is the most suitable solution. After then let us start solving it. That means let us try to find out this y of xt. Let us try express this y of xt in the given form. So that is what we are going to do now. Okay, now so let us find this. Let me explain how the boundary conditions are fixed. You see that boundary conditions. Let me write the boundary conditions one by one. Boundary conditions, see. Now let us write the boundary conditions. Now you see that y, this is nothing but your displacement function y. If I write this, the displacement of function y at a point x at a point t, this is the meaning of that. Now you see that, let me come to this point O. So y of xt at O, I will write it here at O. What is that? At O, you must know that its x value is 0, correct or not? And let the time be anything, whether t be greater than 0 or let it be equal to 0, we are not bothered. So you see that this is nothing but y of 0t, in the sense that at any point of time, at the initial point or at one end, that is x is equal to 0, what happens? So when you stretch a string between two ends, then you see that at the end points there is absolutely no vibration. Displacement, vibration, you can think it of as vibration. So you see that there is no vibration or displacement at the terminal points. Okay, so you see that this y of 0t is equal to 0 for all t. This is for all t. In the sense, whether at any point of time, that is the meaning of that, at any point of time t, this y of 0t is equal to 0. So this is, I hope that you are able to understand. Likewise, someone listening here can tell me what is this y of lt. What is y of lt? At the other end, what happens? Other end is also fixed. It is totally fixed, and that there is no vibration or no displacement of any points in that particular end. So you see that this y of lt will also be equal to 0 for all t. In the sense, for all t means for t greater than or equal to 0. Whether it is equal to 0 or greater than 0, that point is not at all disturbed. Then the next one is, you see that I will write it as 0x, see x, I will write this as y of x0. You know what is the meaning of this? The y of x0 means what? See, this y of x means it is whether the string is pulled to a distance and released, or whether it is tapped so that it gets motion, it starts vibrating. So you see that what is the formation that it takes at time t is good. See, it is now totally, you see that it is flat, it is horizontally placed, and there is no, you see that it is not subjected to a change so that it will start vibrating. It is not like that. So you see that it stands flat, and there is no y of x0 is equal to 0. This is y of x0 is equal to 0 at time t is equal to 0. You know what is the meaning of this? That is, the string lies flat, it is horizontally placed, and at time t is equal to 0. At time t is equal to 0, there is no change in the shape of the string. It lies flat on the ground like. So that is y of x is equal to 0 is this. Then I will talk about what is called your dou y by dou t. You know what is the meaning of this? Dou y by dou t is nothing but the velocity. This is nothing but your velocity. This is nothing but your velocity, and velocity of this at velocity of this at time 0. See, velocity of this at time 0. You see that the velocity of this at time t is equal to dou y by dt at time t is equal. That means the string is given a force to vibrate. There is an acceleration given so that it starts jumping up and down, and that is called your velocity. And that velocity of the string is given like this, and it is given that this is your, I will take this to be my this I will call it as 4. This is 1, this is 2, this is 3, and this is 4. So you see that this is your 4. That means what? Your fourth boundary condition is this. See, it is given v of v, and this v is nothing but dou y by dou t. This is nothing but what? The velocity at any point, that is the speed with which it jumps, is y of at any point, y of xt, it jumps. That is, at any point you take the function, the displacement, there is a displacement, the speed of displacement you can call. So you see that is dou y by dou t is equal to v of x0. That is equal to what? It is equal to cx for in the interval 0 to L by 2, and it is c into L minus x in the interval this. So these are the boundary conditions. So I am able to write the boundary conditions first. So you must be very clear of what you are writing. So these boundary conditions are over, and the most suitable solution is y of xt is equal to a cos px plus b sin px into, it is c cos pat plus d sin pat. So you see that this is the solution. I will call this as my 1. I will call this as my this one. Now you see that this p and a they are all only constants that are coming in the problem, So you see that there is nothing to worry on this. Just leave it like this, and you will understand more if I while doing the problem. So don't worry about that. So you see that this is y of a cos px plus b sin px, and this is c cos pat and d sin pat. Now this is a solution, most suitable solution for this one-dimensional wave equation. So I have written first the boundary conditions, then I am writing the this one. Now your problem, your responsibility is now to find the values of a, b, c and d. If you can find the values of a, b, c and d using the boundary conditions, your problem is over. Can you understand? Automatically you will arrive at the answer. So my job is now to find the values of a, b, c and d using the boundary conditions. So let us start finding the values of all the constants, applying the boundary conditions one after the other. I hope that you are able to understand what I talk in the class. Okay, now let me start doing this. So what is that? This is my one-dimensional wave equation. These are the boundary conditions. This is being solved, and this is the solution of this most suitable solution. Now we will do the problem for finding the values of the constants a, b, c and d. That's all. Okay, now let me start doing this one by one. Let us take this. See, so you see that I will write here. So what is your y of xt? Now y of xt only we must find. So you see that this is y of xt. Y of xt is equal to a cos px. I will start doing the problem straight away. So this is the solution, because time consuming. So you see that I will write this. So first apply y of x0 is equal to 0. First apply y of x0 is equal to 0. So what will happen here now? Y of 0t, sorry, y of 0t, 0t. That is at the initial point, first point, y of 0t is equal to 0. Therefore, y of 0t is equal to, wherever you get x, you put it as 0. So you see that a cos 0 is a and b sin 0 is 0. Don't worry about this. And you write the rest of the things as c cos pat plus d sin pat is equal to 0 as per this condition. Now you see that this t is greater than 0. Try to understand that since t is greater than 0, this bracket cannot be 0. Since t is greater than 0, either a is equal to 0 or this bracket is equal to 0. Since t is greater than 0, this cannot be equal to 0. Here this implies a only equal to 0. Can you understand? So this implies a is equal to 0. Therefore we get y of xt is equal to, where here you put a is equal to 0. So what is that you will get? B sin px into c cos pat plus d sin pat. So this is what you get. So I have applied the first limit is over. Okay. Then take the next one, that is apply y of lt is equal to 0. That means what? You are going to apply the second boundary condition, namely at this point. I told you that at the end points there is no displacement, that is there is no vibration of the points, and therefore it is the y of xt is equal to 0 at any point of time, whether initially or at any point of time it is going to be 0 only. So what is that? Y of lt is equal to 0. So what is that you get? Y of lt. Now wherever x comes, you put it as L. So this is b sin pl into c cos pat plus d sin pat is equal to 0. Now you see that t is greater than 0. T is greater than 0, and therefore this cannot be 0. This bracket cannot be 0. So this implies b sin PL is equal to 0. Here B is not equal to 0, because if you take B also is 0, you are taking A 0, B 0 means there is no solution at all. So you cannot take B as 0. So the only option is sin PL is equal to 0. This can happen only when what? PL is equal to n pi. See, PL is equal to n pi, because when you take n, PL is equal to n pi, sin n pi is equal to 0 for all values of n. So this can happen only when PL becomes n pi. So what is your A? P? P is nothing but n pi by L. So you see that we are able to get one value of one constant, and know that this A is nothing but a known constant. Understand that. Here I forgot to tell you, this A is a known constant. Here n will be known, pi will be known, L will be known, and therefore P is known. So what is that we are able to get? We are able to get the value of the constant P is equal to n pi by L. So you see that I get A is equal to 0, P is equal to n pi by L. Okay, now we have got this n pi by L. End of the problem, let me write P is equal to n pi by L for our convenience sake, nothing more than that. So this is PL, so PA is known, and this is C cos pat plus D sin pat. So this is what we get. So you see that I am able to apply the second boundary condition and get the value of P. Now let me start going for the third. So apply one by one. Apply one by one, you will get the answer. So you see that I am taking the next one. So let me apply the third one. So apply. I gave you this power. Next one is y of x0 is equal to. What is the meaning of this? Initially the string is at rest, and so you see that there is no, it is lying at rest at time t is equal to 0. So you see that y of, I write here, y of x0 at time t is equal to 0. So you see that this is nothing but here it is a b sine px. This is b sine px, b sine px, and p value is known, don't worry about that. So you see that y of x0, this is b sine px, and wherever t is there, you put it as 0. So sine 0 is 0, so you see that c cos 0, which is equal to 0. This implies b sine px into cos 0 is 1, so into c is equal to 0. So you see that b sine px is not equal to 0. We have found b sine px is equal to not 0, so this implies c is equal to 0. So I am able to get the third cause. So what is that we have got here? C is. This implies c is equal to 0. Therefore y of xt is equal to b sine px into d sine pat, that is equal to bd into sine px into sine pat. And you see that this is again a constant. It is a b is a constant, d is a constant, again a constant. So you see that this will be equal to, let me call it as b, and that it is sine px into sine pat. And you see that this is this is y of xt. For this is going to be a string, that is, you are going to be a string, and you are going to find the value of y of xt at every point in the string. So therefore, in general, y of xt is equal to, it is sigma of 1 to infinity bn into sine px into sine pat. Are you able to understand the meaning why I have put here this b and c? You see that up to this you may find it easy to understand this bd, because it is a constant, so I will call it as b itself, some constant b. And that b sine, I use specific letter b for one reason, for a particular reason. So is that b sine px sine pat, but this is for what? Y of xt is x is numerous points lying on the string. So you see that when you are going to calculate when you are going to find the displacement at every point, then you see that the general y of xt should be given as y of xt is equal to 1 to infinity of bn into sine px into sine pat. You see that this we can if you are very familiar with Fourier series, you find that this bn is nothing but your Fourier coefficient. Can you see this? It is your Fourier coefficient. It is standing as your Fourier coefficient, and therefore this Fourier coefficient has to be determined. It has to be determined. And we will, if you find that, then your problem is over. Now, so you see that now y of xt is equal to bn. Now we will apply. So you see that we will we have applied the third condition. Now let us apply the fourth boundary conditions. So what is that? How will you do this? So in general you have got this. Now dou y by dou t at t is equal to 0. At t is equal to 0, that is your what? V of x0. Now you differentiate this. So you see that this is 1 to infinity bn into sine px into cos pat into pa. You are differentiating with respect to t. So this is what you get, and that you see that this value, this dy by dt at t is equal to 0 is given to be your Cx for 0 less than L less than x less than or equal to L by 2 C into L minus x for L by 2 less than x less than or equal to L. So this is given. This is the fourth condition, that is fourth boundary condition. This is my fourth boundary condition. Now you see that this is your f of x. Can you understand? This v of x0 is nothing but your f of x is equal to cx. Can you understand? This v of x0, that is equal to your Fourier series given like this, where Bn is your Fourier coefficient and v of x is nothing but what? Your f of x. So you see that your v of x0 is equal to your f of x, that is equal to your 4. What is your 4? 4 is nothing but your boundary conditions given here. Now you see that this is nothing but your, now this Bn is nothing but your Fourier coefficient which has to be solved. Bn is equal to Bn into P of A. Can you see this? See, I will put it in this way. See, here you can see that this one Bn is here. I will write one more step if you want. So you see that what I have done here is, see what is that I have done here is, see here you see that it is dy by dt at t is equal to 0 is nothing but your, I will rewrite this as 1 to infinity Bn into Pa into sine Px into sine Pat. So this is what, say the same thing I am writing here. This is Bn, Bn is here. When you differentiate, you see that this is Pat into At, this is Pa. This is what you get. Now you see that I write this Bn into Pa separately. See, Bn into Pa, and I call this as my Bn. So what is that? It is 1 to infinity of Bn into sine Px into sine Pat, and you see that this is nothing but your function 4. So this is your what? Boundary condition 4. Can you understand? Now you see that here this Bn, now you see that this Bn is your Fourier coefficient. This Bn is now acts as your Fourier coefficient. Here not, even this one you can take, but let me not take this. So you see that this Bn is your Fourier coefficient, and this Fourier coefficient has to be determined. Now you see that, now I have first boundary condition, I am able to get rid of this A. Second boundary condition, I am able to get of this B. Third boundary condition, I am able to get this C is equal to 0. And fourth boundary condition, you see that I am getting this Bn. Bn is nothing but what? Bn into Pa, or this Bn will be equal to, it is Bn by P, whatever it is. Now you see that my problem is to find this Bn. Bn is nothing but your Fourier coefficient. You see that this Fourier coefficient, how do you give this? Now we have to get the value of this Fourier coefficient. I will write it here, where Bn is equal to, it is what? 2 by L. It is 0 to L. Here you see that it is your f of x into sine n pi x. It is sine px. Actually speaking, you see that it is sine, see, it is sine px into dx. That is nothing but what? It is 2 by L into 0 to L f of x into sine. What is your p? P is n, say I have got n pi x by L into dx. And you see that this f of x is nothing but your velocity function. This is equal to f of x is nothing but what? This is nothing but your f of v. This is nothing but your v, which is given as what? This is equal to cx and c into L minus x, 0 less than L 0 less than x less than L by 2, it is L by 2 less than x less than or equal to L. So you see that in the place of f of x you have got your v function here. So you have to put this v function. So I will start doing this. So what is that you will get here now? So you see that this will be nothing but, this is nothing but 2 by L into, it is split into two functions, two integrals, 0 to L by 2, 0 to L by 2, it is Cx into sine n pi x by L into dx, plus it is L by 2 to L, and it is C into L minus x into what is that? It is sine n pi x by L into dx. So this is my, now you see that you have to integrate this, you have to integrate this, solve this, you will get the value of Bn. Substitute Bn in this, what? This is your 4 means you call this, this is a 4 means this one, this one. So you call this as your 2, call this as your 2. So this sine px is equal to 4 means this is equal to, if you want I can write this as Cx 0 less than x less than L by 2, I will write it here, L by 2 C into L minus x 0, x L by 2 less than x less than or equal to. This is, you call this as your, so call this as your 2. So this is your 2, that is, this is, I will call this as your what? 2. Okay. Now this is what we have. Now I will find the value of this Bn and then go to capital B, because I want the value of this Bn. We will go to that and get the answer. Now you see that, so this Bn is nothing but what? This is what we have. Now let us start integrating this and get the value. What is that you get here now? So this is equal to, so you call this as your 2 by L into I1 plus I2. Now let me start evaluating this I1 and I2. So what is that you are having now? So you see that at, okay, let me start doing this. So you see that I will rub off this because I want space. I will rub off this. Here I will do 1. So you see that what is your I1 now? I1 is, see, C into integral of 0 to L by 2 into x into sine n pi x by L into dx. So you see that I will use Bernoulli's method of integration and I will do, so this is C into, this is x into minus cos n pi x by L into L by n pi, keep this in a bracket, and this must be integrated, limit must be applied 0 to L, minus, differentiate this, it is 1, integration of this is minus sine n pi x by L into, already and this is that, L squared by n squared pi squared, this must be 0 to L by 2. So you see that when you apply the limits here, C, so I will write it here, C into, so C into, so when you apply the limit here, C by 2, when you apply L by 2, it is minus L by 2 into, this is, L and L will go off, giving you what? Cos n pi by 2 into L by n pi. And when you apply the second limit, x is equal to 0, so whole thing goes off. Then minus, when you apply the limit here, so you see that minus into minus will make it as plus, take that minus sign outside. So you are left with, now if you put L by 2, it is sine n pi by 2, and when you put x is into L squared by n squared pi squared. So you see that, and when you put x is equal to 0, sine 0 is 0. So this is what you get. You call this as your say A. Call this as your A. So let me go for finding the I2. So this is your I1. So I am able to get I1. Let me start getting the I2 now. What is my I2 now? So I2 is, see here again, your I2 is where? It is your C, and it is what? It is, I will straight away start doing this. This is your I2. So you see that L minus X into, see, L minus X into, same as this. It is minus cos n pi x by L into L by n pi, and this is from what? It is L by 2 to L. So L by 2 to L, because the limit is from L by 2 to L, and it is plus, open a bracket. You see that the differentiation of minus x is minus 1 into minus sine. It is sine n pi x by L into L squared by n squared pi squared, and this is from what? L by 2 to L. So this is what I get here. Now I will go for this. So what is that you will get here now? So this is equal to C into, when you put L, it is 0. When you put L minus, say this is 0. Then when you put L by 2, see, when you put L, it is 0. When you put L, it is L minus L is 0. Then minus, open a bracket. Now you put, substitute L by 2. So when you put L by 2 minus, when you put L by 2, it is cos n pi by 2 into L by n pi. So you see that I apply the limit L first, then minus, I apply the second limit. So this is what I get here. Then my plus, so you take this here, this is minus into minus is plus, so you take that outside. So you see that, open a bracket like this. Then you apply the first limit. You see that when you apply the first limit L, when you apply the first limit, L and L will go off, sine n pi it is 0. Minus, when you put L by 2, it is nothing but what? It is minus sine n pi by 2 into L squared by n squared pi squared. So this is what, this one is minus, this one is minus, because this one. So you see that this is minus, so minus into minus is plus, plus into minus, this is again minus. So this is minus, because this is minus, so this becomes minus. So it is minus sine n pi by 2. So this is equal to, you know, this is equal to C into, it is, take this inside, so it is L by 2 cos n pi by 2 into L into n pi, and this is plus, and it is L squared by n squared pi squared, see, n squared pi squared into sine n pi by 2. So this is what we have. You call this as your B. Call this as your B. Now you see that I1, I will write it here, I1 plus I2 is equal to, what is your I1 plus I2? So I1 plus I2 is nothing but what? A plus B. I1 plus I2 is A plus B. So if you add, this is minus so much, and this is also same quantity, so this and this will get cancelled, and that this is L square, this is to same quantity, but they are plus, so this will be equal to 2 L squared by n squared pi squared into sine n pi by 2. So this is what you have here. So you see that I1 plus I2 is equal to there's so much. Therefore I will write here. Therefore your Bn, what is your Bn now? So therefore your Bn will be equal to 2 by L into I1 plus I2, which is equal to 2 by L into, what is your this one? It is 2L squared divided by n squared pi squared into sine n pi by 2. So this is what you have. So what is your Bn? So Bn is equal to, it is 4L divided by n squared pi squared into sine n pi by 2. So I am able to get the what? The Fourier coefficient, namely Bn is equal to so much. But what is your y of xt? Y of xt has been found to be 1 to infinity of Bn into sine px into sine pat, where this p is equal to n pi by n. So this is what we have. So I am able to get this Pn, but we know that y of xt has been proved to be 1 to infinity of Bn sine px sine pat, where p is equal to n pi by l. Therefore, so you see that now I'll write here now. So you have got this Bn. What is your Bn now? Bn is equal to your, what is your Bn? Bn is equal to 4L. So 4L divided by n squared pi squared into sine n pi by 2. So these are the values that I have got. So what is that you get here? Now Bn, see we know that, see we have taken, now Bn is equal to Bn into Pa. This implies your Bn is equal to Bn by Pa. What is your Bn now? Bn is 4L divided by n squared pi squared into sine n pi by 2 into 1 by Pa is n pi by L into E. So you see that this and this one C is that C is coming throughout, that C was taken outside. You see that C is coming throughout. So you see that C will be there. See, C will be here. That C is coming throughout. I will just write here. So this is nothing but what here it is. You will get this to be 4 L will go to the top, 4L squared C divided by n cubed pi cubed into sine n pi by 2. See here I will write this because I have forgotten to write this. So you see that your Bn will be equal to 2 by L and within brackets C into I1 plus I2. So this is equal to 2 by L into C into here I have written here, see 4, here you must get this C here this C must be here. So I will write it here. So you see that C into 4L divided by n squared pi squared into sine n pi by 2. So this is equal to, so this is nothing but what? It is 2 by, this is 2L, this is 2L, this is 2. So 4LC divided by n squared pi squared into sine n pi by 2. So here you see that I have forgotten to write this. So this is nothing but what? Bn is equal to 4LC into this. So you see that I have got here this Bn. So Bn is equal to 4LC divided by n squared pi squared into sin n pi by 2 into 1 by Pa. Pa is n pi by L into A. So this gives you what is called your this one. See, you can write this like this and we can verify. So having got this Bn, so what is your Bn? Bn is so much. Therefore I will write here. Therefore, so this is important. So therefore y of xt is equal to, so this is the one. So y of xt is this. So in the place of Bn, you write this as, so sigma of 1 to infinity 4L squared C divided by n cubed pi cubed into sin n pi by 2 into sin n pi x by L into sin n pi at by L. So this is my answer. So you see that this gives you the, what is that? The displacement y of xt at any point of time and at any point of at any point and at any point of time. So this is y of xt. This is the answer. Now you see that you are asked to give the value this in a different way. What is that? Here you see that, note that I will write here, note. See here you see that your Bn is equal to 4L squared C divided by n cube by cube into sin n pi by 2. And that here you see that this varies. Here you see that here this one, you know, this sin n pi by 2 is equal to 1 when n is equal to 1 and is equal to 0 for n is equal to 2 and is equal to minus 1 for n is equal to 3. That means what? It takes plus 1 and minus 1, plus 1, minus 1, plus 1, minus 1. That means what? This has sin n pi by 2 gives values only for odd values of n. For even values, sin n pi by 2 exists for n is equal to 1, 2, 3, 5 dot and is equal to 0 for even n. For even n. Why I write like this? You know, because when you give n is equal to 1, this takes plus, and for 3 it is minus. So it takes plus 1, minus 1, plus 1. So this becomes alternately plus, minus, plus, minus, plus, minus for odd values, but for even values this takes 0. So this is, so what we will write here is that, so Bn is equal to 4L squared by C n cubed by cubed in sin n pi by 2 exists for n is equal to 1, 3, 5, 7 like this and is equal to 0 for even values of n. For even values of n. So first let me explain in this way. You take, since it is going from 1 to infinity, now you give n is equal to 1. Start expanding this. You take this terms which are not involving n. So 4L squared by C divided by pi cubed. Now put n is equal to 1 here. Put this n is equal to 1. So sin pi by 2 is 1. So this is 1 cubed. So 1 by 1 cubed into sin n is equal to, I mean, pi x by L. Put n is equal to 1 and sin pi at by L. Then put n is equal to 2. When you put n is equal to 2, it is 0 plus 0. When is equal to, when you put n is equal to 3, 3 pi by 2 is minus. So it is minus. So when you give 3, it is 1 by 3 cubed into sin 3 pi x by L into sin 3 pi at by L. Then when you put n is equal to 4, this is 3. When you put n is equal to 4, when you put n is equal to 4 here, then sin 2 pi it is 0. So you see that next one will be 0. Then you see that when you put 5, sine 1 for sine 5 by 2 is plus 1. So you see that you will get plus 1 by 5 to the power of 3 into sine 5 pi x by L into sine 5 pi at by L. So you see that it goes on like this. So this is the series that you are having it here. So this is your series. So you see that now in what other form can you write here? So that is what we are going to see. In what other form can I write here? So you see that I will put it like this. So this is the answer. So this is over. So the problem is actually over. Now let me try and write in another form. See what I will do here is, so this is my answer. So this is 4 L squared C. So this is my answer. And this is the expansion of this I have got here. So in another form, if you want to write y of xt is equal to 4 L squared C by n cubed pi cubed into within bracket. See, it is, I will write this as, I will write this as minus 1 to the power of n plus 1 divided by 2n minus 1 whole cubed. Then this is sine 2n minus 1 pi x by L. Then sine 2n minus 1 into pi at by L. So you see that this is true for all values of this. See, this is, I will put it like this. So you put 1 to infinity. So you see that when you put 1, what will happen if you put n is equal to 1? So you put n is equal to 1 here. So 4 L squared C, put n is equal to 1 here. 1 plus 1 is 2, minus 1 to the power of 1 is 1. 2 minus 1 is 1, so 2 cubed. It is 2n minus 1 is 1, so this is sine pi x by L into sine pi at by L. Then put n is equal to 2 here. When you put n is equal to 2, 2 plus 1 is 3, minus 1 to the power of 3 is minus 1 divided by, this is 3, so this is 3 cubed. Then this will be what? Again 3, so this is sine 3 pi x by L sine 3 pi at by L. Then what is that you get here? Then you put 3. When you put if you give 1, you will get 1 plus 1 is 2. If you give 2, 2 plus 1 is 3 minus. If you give 3, if you give 3, 3 plus 1 is 4, it will be plus. So you see that it will be plus. Then 3 means 3 into 2 is 6, 6 minus 5 is 1 is 5, so it is 5 cubed. And this is sine 5 pi x by L into sine 5 pi at by L. So this is what I am. So instead of this problem gets over at this stage, you can assume the values for n is equal to 1, 2, 3 like that and get the answer like this. Or in the place of sine pi by 2, because this is only this value exists only for n odd. This exists, this sine 9 pi by 2 gets the value either plus 1 or minus 1 when n takes odd values. So in order to express that, I am writing in the different form. What is that? I am taking this minus 1 to the power of n plus 1. So you see that this will take care of plus 1 and minus 1, and you see that this, since n is odd, I am writing in the places of n 2n minus 1 whole cubed. 2n minus 1 is always an odd number. So I put it in this way. Now you see that this, instead of writing like this, you can write like this also, the same thing that you will get. So this is your answer and this is also your answer. So this is also your answer. So this is your answer. This is also your answer. So you express this in this form, get this, or you express this in the place of sine n pi by 2, you write it as minus 1 whole to the power of n plus 1, and then you will also get it. But in the place of n, you must put 2n minus 1, because 2n minus 1 is odd, always odd. 2n minus 1 is odd for all n. Yeah, whatever value that you give for n, it will always be odd. Therefore, we express it in this way. So this is how this problem is done. It is a important problem and a standard problem. Normally you get for your examinations, and I will explain to another 1 or 2 problems in the coming days. Thank you. 1 hour 4 minutes I have said.